Hey, how's it going, guys? My name's Daniel, aka HashLips, and welcome back to the continuation of learning Solidity basics. After learning a few different concepts such as variable types, operators, units, we are now going to learn how if-else statements work in code, specifically in Solidity. But mostly, this works very similar to JavaScript or any other programming language. Let's go ahead and do so. I want you guys to create a myifelse.sol file. Go ahead and implement what we have always been implementing, our license, our pragma line, and the contract called myifelse. In order to tell you what an if-else statement is, I think it's better if I show you and also explain. In its core, an if-else statement is a conditional statement that if it's true, it follows one path, and if it's not, it follows another. What we can do is use it like this. Let's go ahead and create a UN256. And let's call this UN256 maybe a reveal state. Okay, I'm going to call it reveal state. And the reveal state's going to be 0. All right. Now, for the reveal state, I'm going to make it public. And just to make it easier for us to increment this reveal state, I'm going to create a public function that will update this state. We haven't covered functions yet, but I want to illustrate this so that when we interact with our contract, you can see how the if-else statement will work. Let's go ahead and create a function and call this add. Okay, add to reveal state. Okay, and then we need to open our bracket and our curly braces. This is going to be a simple public function which anyone outside the contract can call, and all it's going to do is it's going to increment this value. Now, you guys have learned in the previous tutorial that we can increment this by simply adding equals to reveal state plus 1. All right. But what we can also do, and we've learned the shorthand for this, is we can just say reveal state plus plus. Now, the reveal state would increment every time that we click on this function, and it will then show it to us over on the reveal state variable. Next, we're going to have a function that will basically determine our if-else statement, and maybe it will even reveal to us if this product or if this thing needs to be revealed to the user or not. Most people have asked me, how do you create an NFT that needs to reveal certain metadata and another NFT that shouldn't? Maybe this is a way you can do it. You might use a Boolean because it's a much better value to use, but I'm going to use this in this example. So I'm going to create another function, and I'm just going to say this function should say is revealed. Okay, so this function is basically going to if we call it, it's going to return if this product is revealed or not. So we're going to make it public. And then we need to get to our if-else statements. Now, how are we going to do this? Firstly, we need this function to actually return to us something if we call it. So to return something to the outside world, we would need this to kind of do something, right? We need it to return a value. But instead of returning a value directly here, because we haven't worked with functions, I want to do create a Boolean, which is a is now revealed Boolean name, and this is going to be set to false first. Okay, so let's create a scenario in our heads. We are going to say that the reveal state is there, and if we have more than 10 participants, this view state, this is now revealed, should technically when we call the isRevealed to find out if this is revealed yet, should return true to us on this variable. So I'm going to make this public as well so we can see both variables, and then we're going to start with if statement. An if statement is start off by giving the keyword if, then following little brackets and then curly brackets. Again, like anything in code, and like I mentioned, anything that is executed in these two brackets over there, if this condition is true, this will always execute. So we need to be careful what we place in there to make sure that we want to return the right value. So for this if-else statement, we want to check a few things. We would like to see if the reveal state variable, so we can say if our reveal state variable, and remember our operators, is greater than 10. Okay, but this time we can say if it's greater or equal to 10. We want to then set actually our now reveal, right? Our is now reveal. So only if this is true, we want to set our is now revealed equals to true. Okay, we now have changed this variable. So if we call this and this is not the case, it will not set this to true. Okay, and it shouldn't be revealed yet. Let's go and check this base app, this base example out. We need to remember that when we are working with functions, to check to give it the correct attributes here at the end to make the compiler happy. So let's go and do that. Then click on our Solidity compiler section, make sure that it can compile, go to the deploy and run section, go and select our if-else.sol file. Then we're going to clear out our previous deployments and click on deploy. We can now open the deployed contract and actually see that we have a few different variables. We've got our public reveal state, which is there, which is just an integer, which is 0. We have is revealed, and if we call it is this function, sorry, so this is this function, and this is supposed to be setting that. So remember, there's a mistake here. You can't use two equal signs. You have to use a one equal sign, and then we can't make this view, this function a view, because now we are changing the state. All right. Two equal signs is a operator to check, a comparison operator. So we want to create one equal sign. Let's deploy this contract again and let's run it, and there we go. The reveal is now orange, which indicates that it will update and be a transaction. So we have our two global variables, which is now revealed is still false, that is 0. The is revealed is, if we click it, it's just going to check and nothing should change, because when we click on this is revealed function and we now double check our variables, they still stay the same. Even if we keep on clicking it, it will never go into this if statement because the reveal state is still at 0. It needs to be greater than 10. So let's go and click on our add to reveal state, which will increment our reveal state. So if I click on it once and I click here down on the reveal state, I can see that it's now 1. But still 1 is not greater than 10. So even if I click reveal and I double check our is revealed now, it's still false. Only when I click over a certain time and I see that now we're at 7, we are now at 9, and we double check these values, they still, and we click there, we see it's still false at 9. But as soon as we go to 10, because remember, our if statement says if this is greater or equal to 10, and it is now 10. So even if it's greater, if it's 11, 12, 13, it will still be true. But now it's at least at 10. So if we now click on the state variable, we can see that's at 10. This is still false. But now if we click on this function and we now check this reveal, it's set to true, meaning that now our NFT or our product is now revealed to the public only based on variables and if statements. We can do various things. We can even create a string. So a string is a data type which we will discuss pretty soon. But I'm going to make a string and I'm going to call it status. Then I'm going to set the status to maybe not yet revealed. Okay. And like I said, be cautious when you use a lot of strings in your contracts. It does cost a lot of gas, but we need to do this for this tutorial. So I want to go ahead and show you guys. We can now say that if this is 10, right? If this is equal to 10, we now want to set it to reveal. But let's say we want to start building up an audience, for example. We can basically say, if this is 10, then, well, let's make it 5 so we don't have to do so many clicks. So let's say if this is 5, greater or equal to 5, then only do this. If it's not, it will go down into the code block, and if there's nothing else, it will literally exit. But we get to put another else if into it. So an else if, so else if takes another bracket with curly braces. What this basically says, it says if this doesn't pass, go and do this. And then lastly, we can put an else. If everything didn't work, it will execute this one. So this is the structure. You don't always need the else if. You can have just these two. So if this one doesn't pass, then return this. And an example is that we can set the state. So the status here, we can say is now revealed, right? With an exclamation mark or something. And in here, we can just set the status because it's not revealed yet. We can just say maybe something like, nope, still not revealed. And once we have that, everything should be fine. It's moaning because it needs to be on this line, I believe. Or no, we need to close our statement over there. So if we now redeploy this contract, we will get this contract, and we can see that if we click on our status, not revealed, not yet revealed, this is our status, and obviously it's not revealed. But how about we add a few things? We can check the status. Everything is still the same, and it says, nope, still not revealed, right? But as soon as we go over a certain amount and we go and check this, it says now 7. And basically this should be true now if we check that function, so we can check it. And that is true. This is 7 and our status is now revealed. So basically if an else statement works just like that. If this is not the case, else do this. You can also omit the else statement and only have an if statement. And if that's the case, then do it. Otherwise, just do nothing, right? But an if else statement, like I mentioned to you guys just before, if you add the else if, then you add another conditional to kind of ask if this can be true, right? So you can maybe add an intermediate kind of state or some kind of check that you want to do if this condition is not fine. So we can see that, we can say that basically if this is not true, okay, we can at least try something else. We can say, well, if it's at least equal, greater or equal than 3, we can probably start saying almost there, right? And by doing this, we actually see a good example of how an if-else statement works. So lastly, if we go and deploy this, we can just quickly run through it by checking the status, maybe adding 2 to it, checking the status again. It says, nope, still not, because this is 2. We add 1 more, or maybe let's add 2 more. So this is 4. So let's check if it's revealed. It's still not, it's 4. But the status says almost there. And if we do 1 more, we can see that it's now revealed. That is how an if statement works, if else statement works, and if you want to do an if else, and else statement. So sometimes as developers, we need to solve problems, and Solidity gives us tools to do so. So one of the tools that we have, and this is common to all programming languages, are the concept of loops. For loops, while loops, do loops, you get a bunch of them. But at the core, a loop is something that iterates a number of times over an action that you want to perform, and it will stop based on a condition. Let's look at the bare minimum what a loop entails and how we can create one before we can consider even more complex use cases for a loop. So, first of all, we get a concept called a for loop. So, let's go ahead and declare a for loop. I want you to go ahead and declare your myloop.sol, then add the base structure that we are always working with, and let's start here at the top. First, we want to start off by creating a function for our loop to run in. So let's call it function, and we're going to call this function myloop. We're going to open and close brackets. We'll make it public. Open and close curly brackets, and in here we're going to start off our loop. To start off a for loop, you start with the for keyword followed by brackets and curly braces. Everything inside these curly braces will be the thing that runs the amount of times these loops iterate. Inside the for loop, you have to start off with an identifier. So let's give it a uint variable type and call it I. We're going to initialize this variable I and equal it to 0, ending the first statement with a semicolon. A for loop is split up in 3 different sections. First, it's this identifier that we want to determine and define. Then it is the condition. So we're going to write if I is less than, let's make it 5. So if it's less than 5, then we're going to end it. So as long as I is less than 5, this will loop. Then the last section of a for loop is where we iterate and we actually increment our I variable. So you can write I plus plus. You can always make a loop going into a negative value or going backwards by giving this maybe 1,000 and then saying as long as I is greater than 0, for instance, and then you can say I minus minus. Whichever way you're going to loop through, this is the basic structure of a loop. What you can do in a loop is anything. You can perform any kind of action you want to based on the amount of times this is going to loop over. Usually an example of a loop would be to retrieve all the NFTs in a contract based on a certain condition. Maybe at this point you want to kind of iterate over something. You want to find out if something exists in an object or whatever the case might be. You can always use for loops to iterate over arrays and objects. There's a lot of use cases basically for a for loop, and this is the structure of it. There are 2 conditions in a for loop that you have to understand, and that is the break and the continue statement. You can always forcefully exit a loop if you have a condition that's true. For instance, you can say if, for instance, I, which is the variable that we have access to here, is going to be equal to 3. If this is equal to 3, just break. And once we break out of a loop, it stops the execution once I is 3. It does the last thing and then it just exits. You also have the continue statement. So let's say we want to skip a loop when the condition is 2 maybe. So we can say if I is equal to 2, then we would like this to continue. Continue actually skips to the next iteration of this loop. So it's going to just skip this iteration if this is 2 and then carry on with the next one. You might want to do this if you want to work out some odd values or some special condition that you don't want this to execute on a certain condition that you have. This is a base example. And I'm just going to make this function view, or what is it moaning about? Let's just check a loop view relevant can be pure. Okay, this function can be pure because it's literally not even referencing local variables and anything. So it's a very pure function, not affecting our smart contract at all. Next, we get a thing called a do-while loop, right? Or a while loop, basically. Do-while loops have a thing where you define the do, and then it can loop while that condition is true, it will loop. Let's just quickly define one so you can see the base structure of a while loop. So what you want to start off with is your uint, and for this use case, we can use j as our variable name. Then inside here, or just after the variable declaration, you can go ahead and declare this, maybe put it to 0 or something. And inside here, you can say, while my condition is true, just loop. Now, a while loop, it's very important that you always remember to increment your variable that it's checking, because if you don't do that, it might loop infinitely. And then you're going to have a problem with a smart contract that constantly breaks. So you can write if j is less than 10. So as long as j, the variable up here, as long as this is less than 10, do something in here. Okay? So we can do all sorts of different things. So do any actions, like so. And then once it's done with the actions, we have to remember to go and increment j. So we can just say j++. And that is basically how our do loop will work. All right. So this is now just sitting here randomly. So we probably need to include this in our function too. So this is our first loop and it's still in our function. So maybe let's include it here right below. Now I just want to organize the syntax a bit better, like so that it's nicely structured. And there you go. There's the two examples of loops that we can use in Solidity. Please be cautious when using loops, always making sure they end at some point and they not get too big. Loops that get too big have a tendency to take up a lot of gas and can possibly, cause some kind of conflict in your contract. It's sometimes better to find alternative ways instead of just looping over something. Anyway, but this is how it works. Let's go on to the next section. Now we're getting to some fun parts in Solidity. At this point, we're going to learn about mappings. Now, mappings is a very important structure that you can use inside of Solidity to kind of map data, to keep data in one single place where you can refer to it. And it's also a very nice way of indexing certain data together and maybe find a very good use case for this. You will see that in a lot of the examples in the Solidity code, you're almost always going to find a mapping of some sort, especially if you're working with ERC 721 or 1155. All these base interfaces makes use of mappings because it's really a nice way to store data. What is a mapping? Well, let's go and dive right into it. I think you know this by now, but create the mymappings.sol and implement the base things such as the license, pragmaline, and an empty contract. Once you've got that set up, I will show you how to declare a simple mapping. And this is how you do it. You write the word mapping first, and then you go and put brackets. In these brackets, you're going to put a bit of a different syntax that you're not used to, but it will make sense in a second. I'm just for the time being going to write the word key and put an arrow with an arrow sign in there, a equals with a greater than sign, and value. Now, this is the mapping signature. It takes in a key and a value. And a mapping is basically like some sort of dictionary a key value pair that you can store, and you can store multiple of these key value pairs in a mapping. It's basically like having an address book of a bunch of addresses, and then later on you'll be able to look up on that address book what address belongs to which person. That is the basic concept of a mapping, and I'm going to show you how to implement it. We're also going to look at this from a more high level so that we can kind of see a little bit of an implementation and why we would use mappings. Let's go ahead and implement the rest of the mapping. So for a key, this value can be anything such as uint, an address, a byte, it can be string, but for our use case, I think it would make perfect sense if we just start off by using a uint, okay? So we're going to say we want a uint that is going to map to an address, like so. Then what you want to do is make this public because we want to access it, and then let's call it something. We're going to be having fun with this one, so we're just going to call it NFTs, right? We're going to call this actually the NFTs, and these are going to be representations of NFT IDs. So where our integer value is going to be the NFT ID, and we're going to see what does this map to. Basically, which NFT belongs to which address. Perfect. Keep in mind that the key on the, or the value here on the right, is the one that you can update, retrieve, and do all sorts of cool things with. Let's go down and let's see how we can interact with a mapping. Just to put it out there, mappings are not arrays. I know when you start off learning programming, this might seem like a type of array that you've seen before, but it's not. It's basically a key value pair, and if you can compare this kind of in JavaScript, it works almost like an object where you have a key value pair, and that's basically it. Anyway, implementing some functions where we can interact with our mapping will explain this a little bit better. Let's go ahead and create a function for getting back the value of our NFT. So let's call this get NFT. We actually want to return the value. So get owner of NFT. Let's make that a function. Let's make it public and open our curly brackets. So our purpose for this get owner of NFT is basically going to be a function we would like to call, and we would like to pass it in an ID, basically an integer. So we are going to say we are going to give it a uint256. We're going to use underscore syntax here, and I like to use underscores, and the reason for that is then I know that that is a parameter that's being passed in, and not some other variable that I'm using. We're going to call this the ID, and in the function we need to basically return it. If you return in functions, like I mentioned, as always, we will get to functions, but if you need to return, you can say that this function returns not a uint. This is going to return an address because that's what we want. So we're going to return an address to the user. And what address can we return? Well, in order to access the value of the address based on an integer that we've mapped it to, we can simply write NFT, then put our square brackets and pass in the ID. If this ID has an assigned address, it will look it up and basically return to us the value that this ID portrays. Imagine this to be 0, and this is now 0. So just for a second, imagine that we're not using parameters, but we enter a 0 in here. This mapping will give us back the address that the ID of 0 is pointing to. So that's the only thing you have to understand with mappings. It's very simple. Anyway, we have to return something from this function. So we can say this should return this address and we can close it. Now, because we are creating a return value, we can also make this just a view because we're not changing anything in this function on the smart contract, and that's basically what this is asking us about. The next function that we would like is for us actually to be able to set our NFT to the owner. Now, usually in smart contracts, this automatically happens for us on an NFT ERC 721, where as soon as you mint something, we increment and we add the ID to a person. So let's go and implement that kind of flow so you can understand mappings. What we need to do is we need to create another variable, and let's call this counter. Our counter variable is going to start off with 0. Then we're going to create the function down here and we're going to call it mint NFT, like so. We're going to open our brackets and then put curly braces, open them, and all we want to do from this mint NFT is we want to basically use this counter and update the NFT's value of that counter, of that key, to the new address. So we would like to pass in an address to where we want to mint this new NFT to. Let's give it an underscore address, and then after this we can call this public, and that's about it. Now we need to go and add this to the NFT mapping. So let's say, for argument's sake, we can only mint one NFT per time for an address, and it's going to be a very basic implementation. We can go and say, well, NFTs, we want to set the NFT where the counter is at currently. So currently counter is 0, right? So we're going to set this counter is going to be equal to the address. Now remember our one equal sign, we are assigning a mapping of 0 now, the index of 0, to the new address. But there's a problem if we don't change something in this function. If we call it again, it's going to constantly put on a key 0 the same address or a new address, but it's always going to use 0. Therefore, we need to increment the counter after we are done, like so. And this is the core concept of actually adding and showing what's on a mapping. Let's go and deploy this smart contract over here. Let's remove the previous one, select my mappings, and hit deploy. We can now see that we have a few fields, and we've got the NFTs field. Now you realize that it has an extra value because we can't just simply call it, we need to provide it an ID. Let's provide it with ID 1 and see what it returns. It returns the default of an address because there is no address associated with our theoretical NFT 1. Now let's go ahead and do some minting and let's see what happens. Also, if we query the owner of this address, it also has no address, so it returns that. Let's go ahead and copy some addresses and let's mint some NFTs. We're going to put an address in this mint NFT field. I'm going to hit mint. I can also expand this function so it's much better for me to enter values, especially if there's a lot more fields. Let's grab another guy. Let's grab his address. Let's paste it in there and transact. Let's actually give this guy about 3 NFTs. All right, and there we go. Now, what happens is, if we return this ID now of one of the NFTs, just to look it up, we will see that this person owns this NFT. We can also do it through our function that we've created over here. But because this mapping is public, that's why we see the NFTs getter automatically there for us. So that means in theory, we do not even need this function that we've written, because just by making this mapping public, it will already give us this getter function where we can query the mapping and see who owns these NFTs. And that's what I just wanted to mention. I'm going to leave this in here because the best practice would be to not make these NFTs public, keep it private, but remember, when you don't specify a access type of it, then it won't access it at all. So if we now go ahead and redeploy this, you will see that we only have our getter and our mint NFT. And that's a very basic example of an NFT kind of contract. Obviously, there's a lot more going into it, but it is a very good explanation of what mappings are. So let's look at arrays. Now, arrays are very cool types that you can declare where you can actually have a list of elements in one variable. This is not like a mapping, where a mapping is more like a dictionary, a value key pair. Arrays are just a list of elements and it's zero index, meaning that your index will start at 0. We'll get to that, explaining that in just a second. What you want to do is get started by creating your myArray.sol, creating your standard structure. Don't forget your license, your pragma, and your contract. I'm going to be saying that every time, yes, because it's very important to get the initial syntax down. Next, we have a few ways of declaring an array. We can declare numerous different arrays consisting of booleans. We can create arrays of strings, arrays of integers, uintegers. We're going to stick with uintegers for this example. So declare a uint, and then the syntax, you have to add the square brackets to declare that this is an array. Imagine the square brackets are just something to contain things in, and that's why you specify it there as the type. Then we're going to make this public, and we're going to give it a name. So we can just call this array _1 maybe. So this is our first array. The second way of declaring an array is basically doing the same, but this time declaring the name, and then let's make this 2, but then equaling this actually to some data. So we can already say that our data is going to be 3, 2, and 4. Okay, and then the last way of instantiating an array is writing your data type, specifying the brackets, but this time putting in an actual value. This value, and I'm also going to make this public, and we'll call it array3. This value over here, specify the length of the array. When you've specified an array, whether it's fixed or not, basically if you specify an array like this, it's not of a fixed length, and also like this, but if you specify it with a fixed length, it's only going to ever contain 5 actual elements. So you can have different ways of specifying it. But when you have an array, you can check numerous things. So for our array 1, we can check things like, for instance, the length of the array. How do we check that? You say dot length, okay? And then on dot length, you actually get the length of this array. Now, obviously, it's going to show me an error because I'm not assigning this to anything. But basically, dot length, for instance, this array would be 0. For array 2, if we were to say this is 2, then we would get the length of 3. But remember, because it's 0 indexed and we want to maybe grab this number 2 over there, the value 2, in our array 2, how do we get to that 2 value? We have to specify here and give it an index of 1, much like a mapping, how we read from it. Arrays do the same, but you read with their index. Now, 2 is sitting at index 1 because arrays are 0 indexed, like I explained. So number 3 would be 0, 2 will be sitting at 1, and 4 will be sitting at 2. So that's just the index that it goes on and on and on. So it just starts from 0. That's all it means. Next, you get awesome things you can do with arrays. You get features, how to add to an array, how to read from an array. Now, I've showed you how to read from an array, which is basically your array that you specify, and you specify the index value of the field that you want. So for instance, if we want 4, we have to write index 2, and we'll get that value. If we want to add to that number 2 array, we have to say push. So push is a method on an array object. So if we say dot push and we push a number, so let's say 9, like so. If we do this, then in this array, the number 9 will be appended over there. The other method that we can use instead of push is pop. Now, pop will basically remove the last element of our array. So if we call this, then 4 will disappear and we'll be left with 3 and 2 in the array. That's basically on a very top level how arrays work. You can also delete a specific element in an array by literally calling the array. So you have to say delete, and then you specify your array. So 3 doesn't have something in it. So let's say 2, and you give it again the index. So this time, let's say we want to delete number 3, we will put 0, and it will delete this object of this index. That's basically how arrays work. And much like getting it and setting it, like we had in our mappings example, this is almost exactly the same. And just to prove that, I'm going to go to my mappings, and let's go and actually go and grab these two functions, and let's show you how similar it really is. I'm just for the time being going to work with, I'm going to put these two functions in here. And for the time being, I'm literally going to only work with maybe array 2. So I'm going to declare array 1 as not public and array 3 as not public, just so that I can show you guys that these won't show up when we compile them. And these will also execute just now and change up a bit. So let's change this up, and let's say we want to get the value of the array. So get value of index, maybe. We're going to pass an index, not an ID. You can call it in ID if you really want to. But we're going to do this, and what is it going to return? Well, it's going to return a UN256. And the thing we need to change is this, and we're going to pass the ID. And there we go. There our function is updated, and we will now be able to get the value of that index. Next, how do we add to array? So maybe let's actually delete this function and rather copy and paste this to say modify or add a value. So add to array. Okay. And we're going to say this is going to be our value that we want to add. And we don't want to really say index, because we're just going to push it on. We are going to return nothing, so we don't have to return anything. But what we do want to do is we want to say that our array number 2, we're going to use the dot push. So dot push, and then what we want to push is the value. And that's all we really want to do. Now, I see that there is a issue. Let me just see. Is declared as view. Okay, so this function is declared as view. We will still get to that part. It can't be declared as view because it's now actually changing our state variables. Let's run this program and show you how it works. So if we go to my array contract and we say deploy, we go down here, and like I said, we don't see array 1 and 3 because we've hidden them and they are now private. If we go and select this array and query it, we can't query it directly. Remember, we can go, however, specify a value and call it, and this won't have a 4, but it has a index 1, it has index 0, and exactly how I explained to you guys, you see here where it says 0 index, it's number 3, and there we get the value 3 down there. And again, we probably don't need this public, this to be public, seeing that we have a getter. So I'm just going to take this off for now. because I want to show you guys the best practice of doing smart contracts, and that's not to reveal all your variables. So anyway, we have got this function that we can get the index of. So let's actually go and expand this function. Let's give it the index of 0, 0, and call it. We can see that we get 3 returned, which is this value over there. If, like I said, we wanted the value 4, we have to pass in here, remember, 0, 1, 2. So we'll pass in the second index of our array and we get the value 4. If we want to go and add to our array, and let's add the number 42 for the lucky 42, we append it and it did do something. We can now go ahead and query index 3 and see that it is indeed 42. And that is a basic example of arrays. Alright guys, in this last example for this video, at least, I'm going to talk about enums. Now, enums are something that is very cool because sometimes you want to have state inside your smart contract. And when I talk about state, I'm talking about states, maybe rarities for an NFT or some kind of way of determining the day of the week. But you don't want to refer to these things as strings, first of all, because strings are error prone and you can't always have errors in your code. And secondly, you need some kind of way of making it very nice and clean to read the code. And that's where index comes in. Think about it like this. If we had 3 types of different rarities, and we declared each rarity to an integer value, we could obviously say that we have an int, let's make it 8 just to make it clear, and we can basically say that well, we have a rarity, so we can say a rarity, and our rarity value is going to be equal to 0, okay? So now our rarity over there is basically going to be what our state is. And imagine this, we say that 0 is original, and then 1 is going to be rare, and then 2 we want to be our super rare. Okay, perfect. Now for us it's going to make sense to go out through the code and sometimes do if checks to go and say, well, if our rarity is original or if our rarity is rare or super rare, do this. But now we're going to have to refer to it if rarity is equal to 1, if rarity is equal to 2. Now, that's not the worst way you can code, but there is a better way of doing this. And we can achieve this with enums. Enums is basically just a small structure that basically in the back of it all maps integers, right, 0 to whatever, to kind of typed out names and meanings. How do we declare that? Well, first of all, let's declare an enum structure. We can go and say, well, this is going to be a type of enum, and we're going to say this enum has to do with the rarity. Our rarities that we have, you can open the braces, and this might seem a little bit weird, but this is how you declare an enum. And our rarities is original, we have a rare, and we have a super, and then this one we'll have to use underscore rare. Okay, they are our 3 rarities. Now what we can do is we can actually declare a special type rarity now of type rarity. So let's go and do that. So we can say this is now type of rarity. We are taking this type much like we have declared our integers and strings and booleans. It's type of rarity. We're going to make it public so we can read that value. And then we are actually going to say that we're going to call it just lowercase rarity. And there we go. We've basically created a variable based on these 3 possibilities. And on the underlying structure, this is basically saying this is 0, This one is basically going to be 1, and then the last one is going to be basically 2. That's how it works. Now, how do we set and get these values to see if this actually works the way we want it? Well, you'll basically have some kind of way of setting the status. You can always go and set the status by passing in the integer, but usually what you'll do is have a specific function to set it so we can actually see. Let's create a simple function and call it make super rare. Okay, this function is going to take something and make it into a super rare. We're going to declare this function as public, and then what we want to do is we want to actually set the rarity to super rare. Now notice what happens when I click dot. The dot notation tells us that we want to use a property of this type, and it already picks up if I press S that super rare is available. When I press R, it will pick up the rare, and also when I press O, the original. But let's go and pick super rare. Now, because of this function, it will go and update this rarity, and we can check this. It says super rare member not found. Now, obviously, we need to not specify it like that. We need to say that our rarity is going to be equal to rarity.superrare, right? We need to use the top level one and specify it to our rarity. But anyway, that is how you go and make something super rare. So let's go and kick off and just introduce a small concept, which is our constructor. Now, a constructor function is a function that only kicks off once in the lifetime of a smart contract, and it's usually and always on the inception, on the deployment of your smart contract. That's when a constructor gets called, when something gets instantiated and it doesn't get called again. We'll dive more into that on a later stage, but I want to use this because I want to set the base rarity, otherwise it would set to 0, I believe. But I want to make this rare, so I'm going to say our rarity is going to be starting off with a rarity, which is the actual field, dot rare. Okay, so we have got all these things set up. We can now go and deploy our contract, and once we have, we can see everything there. Remember, I left this public so we can immediately access this, and we can see that our type is already 1 because our constructor set it to rare on the beginning, and there it is. Then if we say make this super rare and then we click on rarity, we can see this got set to 2. This is a much better way of coding in your smart contract because you can give actual values to integers that you can use throughout your code, making it, first of all, much more readable and reusable for people who wants to reuse the rarity. Thank you so much, guys, for listening to me on this wonderful tutorial with you. If you have any questions, feel free to ask me in the comments, and also leave a comment if you don't understand anything. I'm sure the community will help out. Lastly, I want to mention that if I explain something and I've done it wrong in your eyes, please feel free to let me know. Don't kill me for it. I am also new to Solidity, but as you guys know, I try my very best to quickly find out the best way of doing things and implementing it. Coding is like learning to ride a bike. Once you've learned to ride this bike, you will have the skills and the tools to learn new languages such as Rust and JavaScript and all these languages that you want to, so that you can code in whatever language you want to, right? And this is kind of the basics of Solidity, but a lot of these concepts fall part of a lot of other languages. Anyway, that being said, have an amazing day, guys. I can't wait to see you in the next video.